Hi, this is Greg from Structural Toolkit. When designing a beam that's on an angle, you may want to somehow incorporate this extra dimension into your design. Often you'll know the horizontal span and also the pitch or angle that your beam will be at. To incorporate this additional length into your span, rather than calculating it yourself, you can use the incline function. To demonstrate this, we'll use the roof beam design we have here. And in the span input, we'll go equals incline, and then brackets, our span, 2000, and then our roof angle, say 22.5, and then end the bracket, and go enter. This will then automatically calculate out the additional length due to our angle, and round it up to the nearest increment of 50mm. If you want to change the significant figures of this function, you can add an additional number at the end, say 3 for 3 sig figs, and go enter. We can now see our input has changed from 2.2 meters to 2.16. Something else you may have noticed is that the function also automatically inserts a comment based on the input, and will update if you change it. Another case where you might use this is for the load width of a flat pitched roof. In our centers, we can input the incline as we demonstrated earlier. But say we also had another roof load adjacent contributing to this load width, but this additional load wasn't on an angle. What we can do is just add on at the end of the function the additional load width. And the column will also update to include this. Now, something to remember about this method is that it typically is a conservative approach. To show this, we'll go to an analysis. Here we have 3 different simply supported beams. The first beam is a baseline 2 meter span with 1 kN per meter live load applied on top. The next beam is then the same beam, but the right support has been raised 1 meter, which gives it a span of 2.236 meters. Our final beam is then just a beam with a 2.236 meter span. This beam is effectively what we're doing with the incline function in our beam design. You can probably guess at this point the reason why this method is conservative. To show this in action, we'll analyse our 3 beams. Our first beam gives us some expected results. Our second beam then has increased reactions and also mid-span moment. However, we can see that the third beam, although it has the same reactions, its mid-span moment is greater. This is because the load on the second beam is applied vertically downward, and so although it will have the same total weight as our third beam, the horizontal span which will determine the moment is less. We also look at our deflection. Just considering the vertical component, it is also conservative. So when using the incline function, you'll need to be aware that it is a simple approach that can be conservative. As a side note, this typically won't be an issue for wind loads as they act perpendicular to the surface of the member. That about covers the incline function. Feel free to check out our website for other tips and videos. Thanks for watching.